Good morning, everyone. I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, I would like to discuss some more problems on method of multipliers. So that is, we are going to solve the linear Lagrange's equation in partial differential equation. So here, linear partial differential equation of first order is called Lagrange's linear equation. Already we know this. So we can take this one in the equation form. That one is P into P plus Q into Q equal to R. So here P, Q and R are the functions of X, Y, Z. These are all details already we know and we discussed before. Just I am going to give the some of the outlines to solve the problems. So here what is the general solution to solve this equation is f of u comma v equal to 0. So here f is the arbitrary function. So we are going to take the two solutions, that is u and v. So here already we discussed in previous videos about the how to solve the given partial differential equation by using the direct method or by using the method of grouping. So today I am going to tell some more problems based on the method of multipliers. So here we can solve the PDE, that means Lagrange's linear equation, by using the method of grouping and method of multipliers. Now here we can observe first one, after giving the equation we are going to write the auxiliary equation, that is dx by p equal to dy by q equal to dz by r. Here in the method of multipliers, here I am going to tell about the method of multipliers. So here in this one, we are going to choose some multipliers, that is L, M, N. So we need here L1, M1, N1 and L2, M2, N2. So why we are taking L1, M1, N1 means we need the two solutions. So first solution we are denoting the multipliers as L1, M1, N1, and for the solution V, that means second solution, we are going to choose multipliers as L2, M2, N2. So how to choose these multipliers means, here we can observe L into dx plus M into dy plus N into dz. So when you are multiplying dx, dy, dz with the multipliers L, M and N, that value, that denominator should be 0. So then we can say that these L, M, N are multipliers of the given solution. So that means here denominator should be 0 by choosing the L, M, N values. So that means for the first solution we are choosing L1, M1, N1, and for the second solution we are choosing L2, M2, N2. So this is the way we are going to choose the multipliers to solve the PDE by using method of multipliers. So here we are going to discuss some of the problems based on this method. So see the question, solve 3z minus 4y into p plus 4x minus 2z into q equal to 2y minus 3x. So first we are writing the given equation. So given equation is 3z minus 4y into p plus 4x minus 2z into q equal to 2y minus 3x. So now we are writing the given equation form is p into p plus q into q equal to r. So now we are comparing this equation with the given equation. Then we can know the what is the p value. So capital P value is 3z minus 4y. Capital Q is 4x minus 2z. Capital R is 2y minus 3x. Now we are going to write the auxiliary equation, that is dx by p equal to dy by q equal to dz by r. So what is the p and what is the q and what is the r we are going to replace here. So dx by p is 3z minus 4y equal to dy by q is 4x minus 2z that equal to, here dz by r is 2y minus 3x. Now we are going to use the multipliers because here we can't do the solution by using the method of grouping. Then we are choosing the multipliers. First I am choosing first set of multipliers, that is L1, M1, N1 as x, y, z. So L equal to x and M1 equal to y and N1 equal to z. So now according to the condition I am going to do this. So dx, that is x into dx. According to condition I will write first, after then you can see here. So L1 into dx plus M1 into dy plus N1 into dz by, so this is the denominator value. Here this denominator should be 0. So according to this, I am writing L1 is x into dx plus y into dy plus z into dz by, here what is the denominator? So x into 3z minus 4y plus y into 4x minus 2z plus z into 2y minus 3x. I am going to calculate this value. That value you can observe here. So 3xz minus x into dx plus y into dy plus z into dz by 3xz minus, here minus 4xy plus 4xy minus 2yz plus 2yz minus 3xz. So here this is equal to 0. So now 3xz plus 3xz minus 3xz plus 4xy minus 4xy will be cancelled. So this one is 0. Now, so here you can see x into dx plus y into dy plus z into dz by 0. So here condition is satisfied. Now I can say that these are the multipliers. Now I can integrate given value. So integral x dx plus integral y dy plus integral dash dz equal to 0 is some constant. So here x square by 2 plus y square by 2 plus z square by 2 equal to c1. Finally, I can write this one as x square plus y square plus z square equal to 2c1. So this is x square plus y square plus z square equal to c1. So this is our first solution, that is u equal to x square plus y square plus z square. This is the first solution. To get the general solution, we need f of u comma v equal to 0, right? So here our u is completed. Now we are going to do the v. How to do the v? Here I need to choose the set of multipliers and second set of multipliers. Here I got the first solution, that is first solution L1 equal to x, M1 equal to y and N1 equal to z. I got the first solution u equal to x square plus y square plus z square. Now I am going to calculate v. So second set of multipliers L2 equal to, here the first set of multipliers, second set of multipliers. So 2 m2 equal to 3 and n2 equal to 4. So now according to the condition L dx plus m dy plus n dz. So here L2 is 2 dx plus 3 dy plus 4 dz. So denominator now. So denominator. So L2 into given value 3z minus 4y plus m2 into 4x minus 2z plus n2 into, that is 4 into 2y minus 3x. Now I am going to calculate this denominator value. So 2e dx plus 3dy plus 4dz by here this is L2 is 2. So 3 into 2, that is 6z 6z minus 4 to the 8y plus here 2, here 3, here 4. So now 3 into 4 is 12. So 12x minus 3 into 6, 6z. Next plus 4 into 8y minus 12x. So plus 12x minus 12x plus 8y minus 8y. 6z, 6z. So it is now 2dx plus 3dy plus 4dz equal to 0. Now I can integrate. So 2 dx integral 3 dy plus integral 4 dz equal to 0. Now 2 integral dx, 2 is the constant taking outside, 3 is the constant taking outside, plus 4 is the constant taking outside. So here 2 integral, so 2x, 3 integral dy, 3y, 4 integral dz, 4z. So this is the some constant here. Sorry. So after taking giving the integration here, we'll get the constant. So v is 2x plus 3y plus 4z. So I got the u and v. I can write the general solution. So general solution of given equation. Given equation is f of u comma v equal to 0. What is u here? That is x square plus y square plus z square comma v is 2x plus 3y plus 4z equal to 0. So here we are using the first set of multipliers x, y, z and second set of multipliers 2, 3, 4. Then we got the solution u and v. So this is the final solution, that is f of u comma v equal to 0. This is the way to solve the given problems by using the method of multipliers. So I am going to explain one more problem to get the better understanding about this method. See here, solve y minus xz into p plus yz minus x into q equal to x plus y into x minus y. So now the given equation is y minus xz into p plus yz minus x into q equal to x plus y into x minus y. Here I am going to compare the given equation with the Lagrange's form, that is nothing but P into P plus Q into Q equal to R. What is the P here? So here capital P is Y minus XZ and capital Q is YZ minus X and capital R is X plus Y into X minus Y. Here I can take this one as Y minus XZ, Q equal to YZ minus X and R equal to X square minus Y square. Now here I am taking the two set of multipliers. So first set of multipliers I will take L1, M1, N1 and second set of multipliers I will take it as L2, M2, N2. First how we can say that these are the set of multipliers. So here according to the condition, first L into dx plus m into dy plus n into dz by this denominator. When I am multiplying with the multipliers, the denominator should be 0. So here according to that, first I am choosing L1 equal to x, M1 equal to y and N1 equal to z. Now so I am multiplying the numerator. So x into dx plus y into dy plus z into dz. So why I am writing first this? Before we need to write the auxiliary equation. What is that? Dx by p value is y minus xz equal to dy by u value is yz minus x and dz by r value is x square minus y square. You can write x plus y into x minus y also, otherwise a plus b into a minus b based on the a square minus b square. Now we are doing here x into dx denominator value plus y into dy plus z into dz. So numerator value, so denominator value also we are going to multiply here. So x into dx by, so x into y minus xz plus y into yz minus x plus z into x square minus y square. So now, so this is x dx plus y dy plus z dz by, so here I am multiplying this one xy, with x I am multiplying the denominator minus x square z plus y square z minus xy. Next here plus x square z minus y square z. So here plus xy minus xy. Here a y square z and x square z x square. So here I am getting x dx plus y dy plus z dz by 0. So that means condition is satisfied and x, y, z are the multipliers. So now I can integrate this value, integral x dx plus integral y dy plus integral get dz equal to some constant. So based on this, integral x is x square by 2 plus integral y is y square by 2, integral z is z square by 2 equal to some 7. So x square plus y square plus z square equal to 2c1. So finally I can write this solution as x square plus y square plus z square equal to c1. This is my first solution. So based on the first set of multipliers, I got the solution u equal to x square plus y square plus z square. Now I am going to do the second solution by using the second set of multipliers. You can observe here. So auxiliary equation is same as it is dx by p, dy by q and dz by r. So now I am going to take the second set of multipliers, that is L2 equal to y and M2 equal to x and N2 equal to 1. So according to that, first I am writing the multiplying with the numerators. So that is L2 into dx plus M2 into dy plus N2 into dz by denominator values. So here this is equal to, you can write dx by y minus xz. Otherwise, you can write like this. That will be understandable to you. So, dx by y minus xz equal to dy by yz minus x equal to dz by x square minus y square. This is equal to, so here I am going to multiply with the multipliers. So that is y into dx plus x into dy plus 1 into dz by, these are the numerators. Now I am going to multiply and add the denominator. So y into y minus xz plus x into yz minus x plus 1 into x square minus y square. So now first I will simplify this one. So here y dx plus x dy plus 1 dz by, here y square minus xyz plus xyz minus x square plus x square minus y square. So xyz will be cancelled. So here plus x square minus x square, here plus y square minus y square. So here denominator is 0 means y dx plus x dy plus 1 dz by 0. So here I can integrate the function now. So here y dx plus x dy plus dz equal to 0. Now I can write this one as derivative of xy. So that is integral dz equal to 0. Now I am integrating integral derivative of xy plus integral dz equal to some constant. So integral xy is xy plus z, integral dz is z, that is equal to C1. This is the first solution. This is the second solution. So that's why I can keep some other constant C2. So already I got the first solution x square plus y square plus z square. Now I got the second solution, that is vxy plus z. So this is xy plus z. Now I can write the general solution. So general solution of given equation is f of u comma v equal to 0. What is f of u comma e here? So u is x square plus y square plus z square, comma v is xy plus z equal to 0. So this is the our final solution after calculating the method of after calculating the multipliers by using the method of multipliers. So I am going to explain one more problem. See, solve y minus z into p minus 2x plus y into q equal to 2x plus z. So now I am going to write the given equation. What is the given equation? Y minus z into p minus 2x plus y into q equal to 2xz. So now I am going to compare the given equation with the Lagrange's form. What is the Lagrange's form? Capital P into small p plus capital Q into small q equal to R. So what is the capital P? So that is y minus z. So capital P equal to y minus z and capital Q equal to minus 2x plus y. Here minus is there. So minus 2x plus y, and here r is 2x plus z. So now I am going to replace the q values in the subsidiary equation or auxiliary equation. So dx by p, dy by q equal dz by r. So here they should be ldx plus mdy plus ndz by 0. So according to the multipliers method. So dx by what is the p value? Y minus z equal to dy by what is the q value? Minus of 2x plus y equal to dz by r is 2x plus z. So what I have to do here according to the method of multipliers, first I am choosing the first set of multipliers, that is L1 equal to 1, M1 equal to 1, N1 equal to 1. According to that, first I am doing 1 into dx plus 1 into dy plus 1 into dz. The same I am going to multiply the denominator also. So 1 into y minus z is y minus z. Plus into minus minus 1 into 2x plus y is minus 2x minus y plus 1 into 2x plus z. So plus 2x minus 2x plus z minus z plus y minus y. Now I got here 1 dx plus 1 dy plus 1 dz and denominator is 0. Then when this condition is satisfied, we are going to integrate 1 dx plus integral m into, that is nothing but 1 dy plus integral 1 dz equal to some constant. So integral dx is x plus integral dy is y plus integral dz is z. So that is equal to c1. So I can write this one as a solution, u equal to x plus y plus z. This is my first solution. So according to the multipliers 1, 1, I got the first solution, that is u equal to x plus y plus z. Now I am going to do the second solution. So here to solve the second solution, here there is no possibility to take the multipliers. So that's why I am choosing here. First one, what is the first? I am taking 1 equal to 3. So what is the one? Dx by y minus z equal to dz by 2x plus z. Now I am going to replace the value of y in place of here already I know the first solution, that is x plus y plus z equal to u. So I can take this value as a some constant. So I am taking this one as x plus y plus z equal to e. So based on this I can write the y value, that is a minus x minus z. So I'm going to replace this value in the first member. So dx by, what is the y value? A minus x minus z. Here minus z equal to dz by 2x plus z. So from this I am going to get this value dx by a minus x minus 2z equal to dz by 2x plus z. So now I am going to do the cross multiplication. So 2x dx plus z into dx equal to a into dz minus x dz minus 2z dz. So I am going to simplify this one. 2x dx plus z dx. I am sending this one to the left side. So minus a dz. So plus x dz plus 2z dz equal to 0. So now 2x dx as it is. Here I am to write these two together. So that is z dx plus x dz. Then I can write derivative of xz. So next minus a dz plus 2z dz equal to 0. So now here I am going to simplify this. 2x dx plus, I can write this one as derivative of x into z minus a into dz plus 2z dz equal to 0. Now I am going to integrate this one. So 2x dx plus integral t of xz minus a integral dz plus 2 integral that dz equal to some c2 or some b. Already taken first solution as constant equal to a, right? So here I am taking b. So now 2 into integral x is x square by 2 plus integral d is cancelled. So here xz minus a integral dz is z plus 2 into z square by 2 equal to b. So now 2 will be cancelled here, here cancel. So x square plus xz minus az plus z square equal to b. So now I am going to replace the value of a from the first solution. So I can simplify this x square plus xz. A value is x plus y plus z, right? So I am going to replace here. So minus x minus y minus z. Otherwise, first you write x plus y plus z into z plus z square equal to b. So what we are going to do this here, x square plus xz minus xz minus yz minus z square plus z square equal to b. So here plus z square minus z square cancelled. Plus xz minus xz cancelled. Finally, I got x square minus yz equal to 0. So, sorry, b. So, this is my second solution. What is my second solution? B equal to x square minus yz. Now, I got the first solution and second solution. I am going to write the general solution. So, general solution is f of u comma v equal to 0. What is that? I'll drop this part. So now general solution of given equation is f of u comma v equal to 0. So what is the first solution? That is x plus y plus z, and second solution is x square minus yz equal to 0. This is my general solution. So this is the way to solve the given equation. So sometimes we may get two set of multipliers. Sometimes we may get one set of multiplier, and we can simplify as like this by choosing the grouping method and setting the values like this. So based on the equation, we have to choose the method which is suitable to that equation. So method of grouping, we can solve the two, so we can get the two solutions, then no issue, we can follow the two solution from the method of grouping. If you get the two set of multipliers, if there is no possibility to do the grouping, then only we are moving to multipliers method. So if you have the two set of multipliers, then we can do by using the two set of multipliers. Here I got one set of multipliers and I done one solution by using the method of grouping after simplifying the values. So this is the way we can do, and we can solve the partial differential equation, because for partial differential equation is there is so many variables and there is a difficulty level to solve that problem. So that's why what are the suitable methods to solve that problem, based on that we have to choose that method. So this is the way to solve the given problems. So here I will give one more instruction about the problem to solve this. So x into y minus z equal to p, y into z minus x into q equal to z into x minus y. So we are going to write the given equation. We are going to compare with the Lagrange's equation form. After that, we are writing the auxiliary equation dx by p equal to dy by q equal to dz by r. So we are going to replace p, q, r values. Here we are getting the set of multipliers 1, x, y and z, and 1 by x, 1 by y and 1 by z. So by using these two set of multipliers, we can solve this problem. Already we explained this problem and we can check to get the solutions. So these are the two set of multipliers. Then we can get the u solution from this and v solution from this. Based on that, we can write the general solution, that is f of u comma v equal to 0. Okay, so then this is the final answer for that. So after that, we can finalize the answer. So here according to this, we are writing here dx by p. What is that? X into y minus z. Dy by q, that is y into z minus x. And dz by r is z into x minus y. So after writing this auxiliary equation, we are going to choose the set of multipliers. If you are taking x, y, z, so then we can multiply the numerator. So x dx plus y dy plus z dz. By here, we are going to multiply the denominator to get the 0. Then you can get the solution u. In the same way, we are going to multiply with 1 by x, 1 by y and 1 by z. What is that? Here denominator, we are going to get 1 by x into dx plus 1 by y into dy plus 1 by z into dz. Then denominator should be 0. So you will get the second set of multipliers. After getting this, we are going to do the integration. Integral x dx plus integral y dy plus integral z dz equal to some constant. Here also integral 1 by x dx plus integral 1 by y dy plus integral 1 by z dz equal to some constant. So here we are going to get x square plus y square plus z square equal to some constant. This is the solution u. And here we'll get log x plus log y plus log z. So here we are going to write some constant with the logs. So then log x, y, z equal to log c. So finally x, y, z equal to c2. This is our second solution. I got u and v. I can write the general solution, that is f of u comma v equal to 0. What is u? F of x square plus y square plus z square comma x, y, z equal to 0. So this is the way to solve the given problem by using the set of multipliers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.